Okay, now everything's set up and we can run the model. We can create the model. So we do that like this on our training data. If I haven't skipped anything, it should work. And then we can see how well it does by doing this. Well, actually, why don't we do this first, see what the result looks like. So here's the results. And it's a little different than we've seen before, and as I said, first of all, well, it is different than what we've seen before. Now remember that our model is here, right? Now we haven't done anything like this before because we never did more than like one variable versus another. Now doing one variable versus three others, but actually, as I said before, because these are factors or categorical variables, it becomes even more different than what we did before. And what I mean by that is, so you might think, okay, if we're going to do it the way we did it before, we would get the coefficient for the y-intercept, we'd get the y-intercept in other words, and we get the slope. So if we have two variables, we might get maybe two slopes and the y-intercept, but that isn't what happens here. So before we only got like this, and then one other coefficient like the slope, one other slope. But now we get all of this stuff, and if you look at it, as I said, you probably didn't expect it, and maybe we'll have time to discuss this in more detail in class. But what R does, and fortunately it does it, is it takes the factors and makes basically a it takes the monthly variable, the ordered month variable, and it kind of splits it into each level of that factor. In other words, the levels are the different months. So we have a level for, we have one for July, we have one for October, we have one for May, and for each month it makes it a separate variable, and except for one of the months, usually the first one, or except for one of the levels, usually the first one. So the first one was April, and I don't think there's an April here. So all the other ones it makes one for. Now we'll have to talk about this in class, about these are called, what if you want to look it up on the internet, they're called dummy, D-U-M-M-Y, D-U-M-M-Y, dummy variables. Might be spelled D-U-M-M-I-E, but I think it's dummy, D-U-M-M-Y rather. Anyway, it splits the factors into what are called dummy variables, and if there are n levels in the factor, then there are n minus 1 dummy variables. So it's all except for one of them. So one is not going to be there. In this case, April is not there. And the same thing it does for the days of the week. So I guess probably Monday is not going to be here. Let's see, Thursday, Sunday, Friday, Tuesday. That's all, right? So are we missing something? Thursday. How many do we have? 1, 2, 3, 4, 5, 6. Yeah. So I think Monday is missing. So it does the same thing for any factor. It takes the levels and makes them into these so-called dummy variables, and we have, if there are, so 7 days of the week, so we have 7 minus 1, n minus 1 dummy variables. Okay? So each variable then has a coefficient, just like when we did y and x had a coefficient. Now we have all these variables and they each have coefficient, and what these numbers mean is they tell us what the effect of that particular day of the week is, or that particular month is. Now, what I mean by the effect is, remember we said April is missing. So this number here means compared to April, July has an effect of 1080. So it means that it will increase the attendance. The month of July will be an increase of 1080 as compared to April. And the month of August will be an increase of this, and the month of May will be a decrease of this as compared to April. And then we can do the same thing with the days of the week. Remember, Tuesday was big, right? So this means that compared to Monday, Tuesday will be this much of an increase in attendance. And of course, bobblehead yes is an increase of 9,604 over bobblehead no. And that's really what we were looking for. We were looking to see what the effect of bobbleheads is. And here we get almost, in this run that we did, we get almost 10,000 person increase in attendance when we have bobblehead yes. However, this is not the end, because if you're what we did here is we just looked at how the model worked on the training data. However, what we want to do, we looked at the model on the training data, but what we want to do is, first we're going to actually use it to predict on the training data. So let's see what that does. No, I'm sorry. Now what we do is, we're doing something interesting here. We're predicting, taking the data that we, the training model, where was that? Let's see that. Yeah, we're taking the model that we just made, which was up here, and we're predicting on the same data. So what does that mean? I guess I need to draw a picture here. So what we've done is this is not exactly a picture of what we have, because we have more than two variables, but anyway, in the two variable situation, we have x here and y here. Then we have the data, the black dots, we have the blue line, and when we do this predict, what we're doing is we're saying when x was here, the actual value was here, but the predicted value would be here, this height here, that height here, right? Because that's what we use the line to go up and then say, okay, then we expect y to be here. And like here, the actual value for x, the actual value was up here, but the predicted value is here. In other words, we use the line, the regression line, to make our predictions. And that's what we're getting here. For all the different values in the data that we had, we're wondering what is the predicted, and remember the thing we're trying to predict here in my model is, where is it? Well, let's look here. The thing we're trying to predict in my model, where is it? Here is attendance, right? So that's so what we're saying is here, the first piece of data in our data set that we were working with, which was our training data, we would predict that attendance would be here. The second one we would predict that attendance would be here, and so on. So that's what these are. Now if this is not clear, please talk to me. Okay, and then, so that's what we did here. And then we do something even more interesting here. So we do, it looks the same so far right there, but there's a comma, and then we have this as well. So what is this? The new data is Dodger's test. And remember, we divided our data in, by the way, I said we're dividing it into 3 sets, and I was wrong. We're only dividing it into 2 sets. Anyway, so the test set, remember we had a test set. I think those were the ones where we had 2s as opposed to 1. And anyway, we had a test set. And what we're going to do is, on the test set, remember we built the model on the training set, and now we're going to apply it to the test data and see what that does. Okay, let's stop here and see what happens in the next video.